Bismillahirrahmanirrahim. Assalamu alaikum. This is panel discussion for chemistry AS level. Today in our session we will be mainly focusing on two sections, that is we have got questions from energetics as well as from formulae, equations and amount of substance. So our session will be continuing looking at those questions that we have received from students. So I am Fatma Sherilyn from Center for Higher Secondary Education. Please
I'm Nafla from Villa International High School.
I'm Jitesh from Maldives International School.
So like we have been doing in the previous session, we have got questions from the first part. We will be doing enthalpy questions, and then after that we will be looking at some of the mole calculation questions. Yeah.
So the question number 1 is from energetics, and so at the beginning of this topic you must be taught like what is a system and a surrounding. For example, a reaction mixture with the reactants and the product is considered as a system, and everything outside it, like outside the beaker, is a surrounding. Okay. So the first question is asked like, if boiling is an endothermic process, why is the air around it warm? Okay. Oh, the first question. And the second part, is it or is the air part of the system? It's not. Air is actually a part of surrounding. Okay. And so if so, what would be considered as surrounding? So surrounding is actually, if you have a reaction mixer in a beaker, suppose zinc and copper sulfate solution is reacting in a beaker, that will make a system. And so we have a beaker, that's a boundary between system and the surrounding. Surrounding is the rest of the universe or the world, we can say it is a surrounding. Okay. If like you know that in an endothermic process, system will try to absorb energy from surrounding. Okay. So there will be some kind of thing, sometime some phase change must be there, some reaction, something will be happening there in the system. So our basic understanding is like the surrounding must be cooler than the system. Okay. Logically we can see, even if you apply some body spray, the things get vaporized. So the body actually have a feeling like cold feeling. Same way the surrounding must be cold. But here the problem is whatever the heat energy absorbed by the system is within the system. Okay. That means the energy of the system is actually a bit higher than the surrounding. So there is a possibility like heat energy like move from a higher concentration part to a lower concentration part. So it will travel like that. That make the surrounding air a bit warm. But it is only for like an open system. But I think in a more advanced version you will know about closed system, isolated system. In those systems there is no energy transition between the system and surrounding. But in a normal open system, heat energy will travel from like a higher gradient region to a lower one. So the surrounding atmosphere, the air gets warm.
Okay. Thank you, sir. So the next one.
For the second question, show an application of the formula capital H equals capital U plus simple V into capital V. So in this equation, students might get a bit confused about this equation because this is in advanced thermodynamic chemistry. Okay. So in that case only they will get confused about this one. Basically this is about enthalpy. Enthalpy is a summation of internal energy and the product of P into V work, that is about the work. And another thing is this particular formula. This particular formula is a mathematical formula of first law of thermodynamics. First law of thermodynamics, students know about those things. First law of thermodynamics is the conservation law of energy. So I think this part this is not in your syllabus.
Not in the syllabus.
This is not in the syllabus. In that case, students no need to worry about this equation.
Okay. So mainly maybe when you are going through Cambridge textbooks or some other textbooks.
Some other textbooks.
Yeah,
you might come across this equation.
Yeah.
So in that case, students might have some confusion about
in
this.
our specification, you should know like what is actually an enthalpy change, how do you calculate it, and what are the sign of enthalpy changes. That's it.
Yeah,
And this is a more deeper part which actually like explaining what actually is the total energy of the system, what are the components of that energy part, and how a system changes, how the work is done by the system. Those things are included in this mathematical equation. So
Yeah.
it's better we just leave it as it is.
Yeah. So the important thing is, students, it is important to look at the specification and see what are the components or what are the parts that are included in the specification which are relevant to what we are studying. So because students have asked this question, we thought we will highlight it in this session. So next one is, during an exothermic reaction, temperature of the surrounding increases and the temperature of the system decreases, and the opposite is true for an endothermic reaction. Is this statement correct?
Yeah, that statement actually is correct in one way. Okay.
Okay.
So when you refer to a different type of system and like different type of process, and there is a like a complication of saying it opposite is correct. But logically, if you think, like you imagine the first figure you are learning in the energetic topic is like there is a box kind of setup where you can see arrow going in, arrow going out. It's just to describe you that system absorb heat, so surrounding is losing heat,
Yes.
system release heat, so surrounding is gaining it. That logic, if you use, that opposite statement is also correct.
Okay. So I hope the student who has asked this question have got an idea of the statement now. What is the meaning of 1 mole of equation?
This is a very interesting question. What is the meaning of 1 mole of equation? So we come across this expression 1 mole of equation under the enthalpy change of reaction. Under the enthalpy change of reaction, students might see they have mentioned 1 mole of equation. So in that case, students might get an idea for this 1 mole to this, to whom, to which substance this 1 mole is referring to. So actually, enthalpy change of reaction is the measured enthalpy change when the equation quantities react under standard conditions. So in here, under the we have other enthalpy changes also, as neutralisation enthalpy, formation enthalpy. Those in those kinds of enthalpy changes, we specifically mention about 1 mole of some specific substance. Sometimes 1 mole of this substance. Sometimes 1 mole for this particular reactant, for this particular product. But in here, we are not specifically mentioned. We do not specify anything like that. Yeah. So in that case, but students might get confused about this enthalpy value, because enthalpy value is in kilojoules per mole. Why this is in kilojoules per mole? Students, no need to get confused. This kilojoules per mole value is for 1 mole of equation. No, it is not referring to 1 mole of reactant or 1 mole of substance. It is 1 mole of equation.
So the energy that is given off is per mole of substance.
Mole of a
per
substance,
mole of substance.
So some reactions, when you balance the equation, you can see more than 1 mole is reacting. Okay, in that case, you are calculating enthalpy change for that particular reaction. It might be 2 mole reacting, it might be 3 mole reacting, but if it refers to 1 like per mole, then it is a 1 mole equation.
Okay. Going to the next one, what is a spirit burner and why do we measure its weight after heating?
Okay, so the figure you must have a figure like when you solve unit 1 a paper, a number of papers, you have a spirit burner. Okay, just like a normal old day candle. Okay, instead of kerosene or something in it, we use more like
right?
ethanol. Mainly we use ethanol. Okay,
yeah.
So this burner burn without any smoke. So basically we don't get that dark deposit, black deposit in any part. So in a lab, especially when you heat a test tube, it is really difficult if you have a black coating there. So we need a flame without any unburned carbon in it. So we use the spirit lamp. And this question referred to experimental determination of enthalpy of combustion. Okay, and there will be a spirit lamp with a specific mass of ethanol in it, and then there is a lagging there. You have a beaker in a stand with a specific volume of water there. So in that heat experiments, we do make 4 measurements. The first measurement is you are going to measure the mass of spirit lamp plus ethanol before combustion, and then you are going to like burn this burner for a specific duration. If there is a considerable mass is lost, you will just cut off the fire. Then you will mass the weight of spirit lamp with the alcohol after combustion. That difference will give you an idea about how much of say ethanol burned. That mass you need for the later calculation for finding enthalpy change, which is actually energy transferred in kilojoules divided by how many moles burned. So actually it is delta H is E over N. That N, to calculate that mole of ethanol burned, you need the mass. To get that mass, we have to weigh the spirit lamp before and after heating.
Yeah.
That is actually the purpose of reweighing it.
And also the fuel goes into the spirit lamp, isn't it? So we need to have something that to actually contain the fuel.
Fuel, okay.
So for that purpose we need the spirit burner.
Spirit burner.
Yeah.
And I think there are related question also, you know, we actually have to keep a cap immediately after you just like cut out the fire. You have to keep a cap because the spirit is alcohol is something is highly volatile. Just reduce, just to what do you call, not make much difference in the enthalpy change calculated. You need the exact mass of ethanol burn. So we also have really there is a cap also there for the spirit lamp.
Yeah.
Okay.
So as soon as you replace the cap, we will be measuring the mass. Otherwise, there's the possibility of ethanol vaporizing, right? Due to the heat of the filament. All right. Can you summarize the experimental determination of enthalpy change of neutralization, combustion, and formation? Now, this question, it's I think 3 lessons.
3 lessons.
So we will summarize the important parts of the 3 sections, that is enthalpy of neutralization, combustion, and formation, because we will be not we will not be able to go through all the steps, right?
All the steps.
Okay, so
Okay, this is the
if
practical.
you want, you can use the board.
Okay. So for the enthalpy change of neutralization, we will be first we will discuss about the enthalpy change of neutralization. It is formation of 1 mole of water when acid and base react under standard conditions. So students should know how to perform the practical and do the calculation part. I will briefly explain about this practical. So in here we are using, in your syllabus we are using a strong acid and a strong base in order to do the practical. So there are 2 methods to perform this neutralization reaction. Basic calorimetric method also fine. If not, you can go for a thermometric titration method. For basic thermometric method, what we are doing is we just mix acid and the base, and we measure the maximum temperature reached. So we take 2 readings, initial reading of the acid and the base, and after that we are taking the maximum temperature read. It is delta T, and you know about the calorimetric equation, Q equals mc delta T. By using calorimetric equation, you can find out the heat energy in joules. But for the final answer, you have to be very careful. You have to give the final answer in moles, kilojoules per moles. You have to give the final answer in kilojoules per mole. So in order to take that value, you have to first calculate the number of moles of water formed. So after that, for the final equation, you have to divide the number of the heat energy by number of moles of water, and finally you can get the answer in kilojoules per mole. And you have to keep in mind always the neutralization reaction is exothermic. In that case, make sure to put the sign in front of your answer. So other than this simple calorimetric method, you can go for thermometric titration also. Thermometric titration is titration method. The end point is determined by a temperature change. Okay. So that part also okay. Some students might have done this practical in the laboratory. So in that case, they know we have to take the we have to place the acid in the burette, and we have to take simple calorimeter, and we are adding acid portion by portion. We are adding acid portion by portion, and after each addition we will be measuring the temperature, and we will be drawing a graph. We will be drawing graph temperature against volume added, volume of the acid added. After that you will get a graph, and after that by using that graph you can calculate the enthalpy change of neutralization. So both methods are possible for that one. Right. For the combustion, so like Mr. has explained about this one, we are using the spirit burner, and we have to initially we have to take the mass of the spirit burner. Finally also in this enthalpy change of combustion, the idea is we are burning some amount of ethanol, and we are giving that heat energy for the water. The water will absorb that heat energy, and we are doing the calculation part for the water. The amount of heat energy absorbed by the water by using Q equals mc delta T. Simple calorimetric equation and simple calculation part is there. By using the readings you can find out the enthalpy change for the combustion, and make sure you have to find out the enthalpy change of combustion for kilojoules in kilojoules per moles. In that case, first you have to convert your answer into kilojoules. After that you have to take the final answer by dividing number of moles of ethanol. So that is about combustion. And for the formation, we do not perform any practicals in the laboratory.
Yes.
So, but if you want to find out unknown formation enthalpies, we can go for a Hess cycle.
Hess cycle. Okay.
Okay, there are, okay, thank you. So there are few things, okay, like you all know, in any heat experiment, we start with a temperature measurement, okay. In both experiment, we actually have a temperature measurement, that is the initial temperature and the final temperature, okay. But if you do neutralization, suppose we are reacting hydrochloric acid with sodium hydroxide. So first you are going to like pipette out say hydrochloric acid in a polystyrene cup, then you are adding sodium hydroxide. There are two methods, the students will really know. The first method is like Miss mentioned, add the entire volume, mix it, and before adding and after adding you measure the temperature change. The second method, you add drop by drop, like say 5 centimeter cube, you mix it, measure the temperature, another 5, you mix it. So you get a series of temperature change and the volume. So we are plotting temperature against volume of say sodium hydroxide. So you get two points there. So we are going to draw two straight line. It is going to intersect at a particular point. That point of intersection will help you to find what volume you need for complete neutralization and what is the maximum temperature rise. And we do that because this heat loss we can compensate somehow when you do a series of measurements, okay. And there is one important part we have to highlight here. We are mixing two solutions.
Yes.
It's not like a solid and a solution. In combustion experiment, we burn and the heat energy produced transferred to a known volume of water. So we know the volume of water, that water is storing the heat, so the temperature change of water is enough. But in this case, we might use excess of alkali, but you should know from the graph or by a mole calculation exactly what volume of sodium hydroxide you need for the complete neutralization is a relevant part for us. That volume you need to know. So suppose you add 25 centimeter cube HCl, you add 50 centimeter cube sodium hydroxide. Remember, the total 75 centimeter cube is not a relevant volume. You don't need that. So first you have to find a mole calculation, and you should use a ratio, and you have to find what volume of NaOH is required. So volume of acid used plus volume of base required for complete neutralization. That volume together, suppose 25 more you need, that means 25 plus 25, or you plot a graph from the point of intersection you are getting a volume. That volume only we have to use, and you have to add that volume with the volume of acid pipetted out. That volume is actually the mass we have to use for the first stage of calculation. That is an important part. In most of the time they might give excess of sodium hydroxide, so you will sum up 75, so it's wrong. So we have to calculate exactly what volume of alkali is required. Limiting right? Part we have to remember, okay. In combustion our job is kind of easy, like because you know volume of water is the mass, okay. And
by using this thermometric method, we can find out unknown concentration also.
Okay.
Then there is a third experiment, formation is mentioned, but there is a third experiment also, like zinc and copper sulfate experiment.
Yeah.
That experiment is a reaction, as a displacement reaction. There is a temperature rise, and you have like two methods, directly measuring, or you have a series of temperature measurement is there. So you are getting like a point, so you remember the procedure, 1 minute, second minute, third minute, you will skip third minute, and fourth minute you will add. So you get a series of temperature before adding, after adding, so you get two individual lines there. You have to extend it so that you can get the difference between the two lines exactly at the moment you mix the second reagent. That point will help you to find the actual temperature rise. That is impossible to measure because of the practical difficulties, because the reaction is a bit slow, because of heat loss. So that also is an addition part you should remember, and that too graphical questions usually are in your practical paper, but the combustion experiment in old version paper, even in unit 1 we used to see that. But the other neutralization experiment is in practical, and the recent first paper we have a different one is there. They use a different even calorimeter also, and they ask so many weird questions in that one.
Yeah.
So basically we don't even think that way is the answer is going to come. So I think 2018 or 19 October we have a very different question is there.
Yeah.
So I think nowadays the questions are now, because it's repeated for a number of times, you should expect a modification from the current procedure. So you should know, like it's better if you go for a Cambridge or any other specification, the same heat experiment question. Also the Edexcel version of our syllabus, there are some nice heat experiment questions with a modification there. So better you refer to those, but make sure you strictly follow our specification guideline. Don't think that all kind of question is possible in our paper. Okay, we have teachers. You just, if you find something new, like approach whoever you like to ask, or you are not that much afraid of. So you just approach the teacher and ask, Miss, is it relevant to our syllabus? Should we try this? Especially a student who really want a nice mark. They don't want to lose even a single mark. So it's good if you have an extra effort on these advanced questions. Okay.
It's a matter of just looking at different types of questions, right? So that they can have a way, like their thinking can be applied in different ways, so that they are more open up instead of just sticking to one specific type of question. So it's a good idea, but then you need to always refer to the specification and see if it is relevant to our syllabus. Okay. This is now coming to parts per million.
Parts per million.
Yeah.
Okay. So I think even the last class we had a parts per million question.
Yes.
So this one is a kind of like a simple one.
Yeah.
Okay.
Okay.
So it says in European Union they limited the nitrogen dioxide in the atmosphere. They says in 1 meter cube of air only 0.0209 centimeter cube only allowed. Okay.
Yes.
So two different units we have. We have a centimeter cube term, you have a meter cube term. So you can, like, it means 0.0209 centimeter cube. In the question it says it is in 1 meter cube, right? So this you can convert, or this you can convert. So you have to check the option in which unit your options, the MCQ options are given. So I think in this one it's in centimeter cube. Yeah, I think so. We actually have to convert this one. So everyone know, like, these two have a relation, right? So that relation, if you use, you can calculate it. So like means 0.0209 centimeter cube is in 1 meter cube is how many centimeter cube? You have to convert it. So you have to find then how much is in 10 to the power 6 centimeter cube. When you cross multiply, you get the answer 2.09 into 10 to the power minus 2. Okay.
Yeah.
So just like, make sure your conversions, the unit conversion is something they usually asked in MCQs. In a very hurry way, we might even miss that one is in centimeter cube and the other one is in meter cube. So in this case, check the option. If the option answer is in centimeter cube, search for, like, in this case it is expressed in parts per million. So it's okay, you make the units in a basic unit conversion is enough, and you get an answer that is 2.09 into 10 to the power minus 2 in million. No? So in
Parts
this,
per million.
okay.
Yes.
This is the way you do this ppm question. I think it's clear. Okay.
So the main part is conversion of centimeter cube to meter
meter
cube
cubes.
or meter cube to
Cubes into
centimeter cube.
centimeters.
So they must be in the same unit. And also if you can apply the parts per million for volume, right? Where they have the volume of the pollutant over the volume of
the
air
air
into
into
a million,
Million. That's
then they can still find the answer.
okay.
Now this one is a sample of blood plasma contains 3.10 milligrams of sodium ions in 1 centimeter cube. The concentration in mole per dm cube of sodium ions in the plasma is.
Okay. So this is a very basic mole calculation question. Right. A sample of blood plasma contains 3.10 milligrams of sodium ions. In here, you have to keep in mind this milligrams is there. So better first convert this milligram into grams, because always in mole calculations you are dealing with grams. In that case, better to convert this into grams first. So it is sodium ions, it is 3.10 milligrams. So in here you have a unit conversion here, 3.10 milligrams into grams means 3.10 into 10 to power minus 3 grams. Right. First we have to do the conversion part. After that again we will read the question. So in 1 cubic centimeters, in 1 cubic centimeters of blood plasma, we have 3.10 into 10 to the power minus 3 grams of sodium plus. But they are asking the concentration in moles per decimeters cube. You know, in here also there is another conversion, 100 cubic centimeters equals to 1 decimeters cube. This part you should know, and this conversion part you should know. These are the main two conversion parts you should know, and after that convert this one. This is in grams. So in here also there is another conversion. Find out the number of moles of sodium. Number of moles of sodium. In order to find out the number of moles of sodium, you have to divide it by 23 molar mass of the sodium grams per moles. So you will get the answer 1.347 into 10 to the power minus 4. It is in moles, right? It is in moles, but it is in 1 cubic centimeters. It is in 1 cubic centimeters. In 1 cubic centimeters we have 1.347 into 10 to the power minus 4 moles. So they are asking in 1000 cubic centimeters. This equals to 1 decimeters cube also. 10 to the power minus 4, 10 to the power 3. So in here you will get the answer 1.347 into 10 to the power minus 1, and give the final units properly, moles per decimeters cube.
So this one is also a multiple choice question, and you can see that the amount of time that you have to spend in working out these questions. It's a bit challenging, especially when you have multiple choice questions, right?
So while you read, you should get an idea. I have to make moles, okay, and I have to express that in dm cube. So in the first stage, you can start 3.10 into 10 to the power minus 3 in 1. Okay, that means 3.10 into 10 to the power minus 3 divided by 23 mole in 1. Then how much is in 1000? So that way, if you like plan, even in 1 or 2 steps, you can get the final answer.
Yeah.
Okay.
You can skip one or two steps and you can get the answer quickly.
Yes.
For the MCQ questions, the main thing is students struggling with the time.
With the time, yes. And if you can do it in a shortcut. And you have to have confidence in doing so. All right. Going to the next one, this is a bigger question.
So I will read the basic question, okay? Your magnesium chloride and silver nitrate reacts. It forms a white precipitate of silver chloride. That is the actual equation, okay? The statement says we use excess of silver nitrate, okay?
Yeah.
That statement will give you a relief that you don't have to go for all the calculation. One of the only two reactant, one reactant is excess. So the other reactant's mole will decide how many moles of product is going to form. And that mole is given. So it is 0.001 mole magnesium chloride is reacting.
Yeah.
That means one magnesium chloride will form 2 silver chloride. So 0.001 mole magnesium chloride will form a double, that is 0.002 moles of silver chloride, okay?
Yeah.
And they need you to get the mass. So just multiply it with the molar mass of silver chloride, that is 143.4. So basic answer is 0.002 into 143.4. So that will be 0.287 gram. So there are when you see this question 5-6 lines, you might think, oh, so many things are there to do, but actually it is just a simple logic of like skipping the mole calculation, and they didn't even give any other mole. If you don't know anything, but still you know there is one mole, one particular reactant's mole is given. So you don't have to worry then. There's nothing there to calculate. Use that, use the ratio, find the moles of product and find the mass of product. So it is mole mass calculation is in this particular MCQ, okay?
Yeah.
I think the new version paper, difficult mole MCQs are not there, no? It's kind of simple, I believe, these kind
Quite
of.
direct, right?
The direct.
Yeah.
And in our old peers, EdExcel, there are so many questions like it's need more time.
It needs a lot of time. But the difference in our current paper, the new syllabus paper, is they need more theory. And also students need to understand what they are learning and be able to write it down. There are those 6-mark questions where they have to organize their answers and then write on a particular topic.
Yeah.
So unless they are very thorough with the content that is being taught, it will be very difficult.
Yeah, I found like there's a 6-mark question about intermolecular force.
Intermolecular
And there was a
force.
6-mark question about reaction between halide, solid halide and sulfuric acid.
Yes.
So when that 6 marks make some worries. So they should like really be limited time they should arrange it, like it's also a difficult thing.
And that is the challenge I think that we will find at this moment in time, because they have to organize their answers, they have to be familiar with the content, and then the layout must be there in such a way that the examiner can read through and understand. So laying out in a logical manner.
I think it's also important the unit conversion. There are a lot of questions with the unit conversion also.
Yes. And students do many mistakes also in this unit conversions.
Then the ideal gas.
Small mistakes.
The ideal gas equation also, there are 6 marks, 5 marks question there.
Yes. So the next one is the molecular formula of phosphorus is given. What is the percentage by mass of phosphorus in this oxide?
Okay, first find out the molar mass of P4O10.
Okay.
So that is very easy to find out the molar mass of the molecule. So it is 31 phosphorus. We have 4 phosphorus atoms there, 4 into 31 plus we have 10 oxygen atoms, 10 into 16. By that calculation part you can get the molar mass of the molecule. And they are asking what is the percentage by mass of phosphorus. So you can see in 1 mole of P4O10, 4 moles of phosphorus is there. 4 into 31 is the mass of the phosphorus. So we have to express as a percentage mass of the phosphorus divided by the molecular mass into 100%.
And you should be getting 43.7% as the answer, right? So first work out the mass of phosphorus, that is 4 times 31.
Yeah, total mass of phosphorus over total mass of the molecule.
Total mass of the molecule, and multiplied by 100. Next one is what mass of anhydrous sodium carbonate is needed to make 50 centimeter cube of 0.0800 mole per dm cube solution of sodium carbonate?
Okay, so this is a basic, very basic question, and you also need to know this is the basic question we actually refer to prepare a standard solution. Okay, so in this one the question is to find what mass of the salt, anhydrous sodium carbonate, is needed to prepare a known concentration of sodium carbonate solution in a specific volume. So first you should know how many moles of sodium carbonate is there. So first you should find the moles. So this one also I will show. So first you should find moles of sodium carbonate, and there is something here. They highlighted it is anhydrous sodium carbonate. Okay,
Yeah.
and so find the moles. You need the C concentration volume relation. So it must be 0.08 okay, 00 into a 50 divided by 1000. This will give you the moles. Okay, and this mole you need step 1 to find the mass. So the direct calculation, you know this many mole is required, so you just have to find the mass. Step 2, finding mass. Actually 1 mole of anhydrous sodium carbonate is 106 gram, and you know this answer, how many mole there. So this mole is how many gram. So just a cross multiplication is enough to get the answer. It's a somewhat a straight question also. So I hope the answer is what is this? It is 0.424 gram. Okay, I think this you can skip these steps if you really know, like you can just use a calculator and get this answer. And the only part extra job is you have to calculate the molecular mass of sodium carbonate, and sometimes you might even miss the actual molecular mass. Maybe there will be an option with calculated with the molecular mass using 1 sodium and carbonate. So whatever you do, your one answer will be in one of the option. So please make sure you calculate the correct molecular mass of sodium carbonate. That is the only part everybody make mistake. The rest is a simple mole calculation. Okay.
Okay. About the standard solutions, can you explain how it is done?
There are like you can prepare a standard. So first of all, if you use a solid to prepare a standard solution, there are some qualities we are expecting. Like it must be a pure solid. Okay, it must not absorb moisture. Like we actually have to accurately weigh a specific mass of that solid, and it should not absorb moisture from the surrounding. Okay, and it must be soluble. The most important thing is whatever the solvent you choose, that solid should completely dissolve in that solvent. That 3 main qualities we are expecting. Okay, suppose in this case we have to accurately weigh 0.424 gram of sodium carbonate. Okay, then first you should transfer that solid in a step by step. If you talk, you transfer that to a clean beaker, and you dissolve that in minimum amount of distilled water. Okay, and even that minimum is not relevant in most of the time, but in reality we have to add a little of minimum required distilled water. So you dissolve it, then transfer that completely to in this case we not relevant volume. We don't have that kind of volumetric class. Usually it is 100 or 250. You transfer that to say 100 centimeter cube of volumetric class. Okay, when you transfer, when you do in a lab, there are a lot of things we have to keep. We have to use a glass rod. Through the glass rod we have to add it. We have to keep a funnel, and just to make no problem, there is a paper strip in between funnel and the tip of the volumetric class. Okay, that's not relevant when you write an answer. So you transfer it completely to the volumetric class. Then you have to rinse the beaker with a minimum of distilled water and transfer the remainings to the volumetric class. Okay, in reality we have to even wash the glass rod. Okay, and we have to even wash the side of, like, inner wall of the tip of the volumetric flask. So make sure everything is inside the volumetric flask. Then you make it up to the mark with distilled water, and when you make it when almost near the mark, you stop adding free addition. Then we will use a dropper or filler to add and make it up to the mark. Okay, then you close it and then you have to mix. Okay, that mixing really when you do that, you can't mix like this way. The shape of the flask is like that. Even if you do like that, it's not going to make a uniform solution. You have to make cleanse it, okay, and do it like that. Then make it like 3-4 times just to get a uniform solution. And those things are not relevant when you write. You just have to write, make it up to the mark, and then mix. So 4 steps: transfer the known mass of solid, dissolve it in distilled water, transfer it to volumetric flask, transfer the remainings to volumetric flask, make it up to the mark, and mix.
Okay.
That will give you a standard
Full marks,
solution
right?
of sodium carbonate.
This one is parts per million.
Again, parts per million question is there, very straightforward question. A sample of air with the mass of 5 kg contain carbon monoxide with a concentration of 12 parts per million by mass. What is the mass of carbon monoxide in the sample of air? In here they have given the parts per million. You have to find out the mass of carbon monoxide.
Carbon monoxide.
So you can straight away you can use the formula given. It means 12 ppm equals to carbon monoxide, mass of the carbon monoxide over the mass of the air. 5 kilograms you have to convert into grams into 1 million. Then you can get the final answer. The final answer would be 6 into 10 to the power minus 2 grams. So, so the answer is in grams. So in that case you have to convert that 5 kilograms into grams. 10 to the power.
I think it will also work it out.
Yeah.
So it says to find the mass. The concentration of carbon monoxide is 12 parts per million. That means 12 gram. Your answer option is in gram. That means 12 gram is in 1 million gram. That is the meaning of 12 parts per million by mass. Okay.
Yeah.
Then you have to find how much is in 50. No. Sorry, 5. No.
5 kilograms
5 into
10 to the power
3 grams. This, when you cross multiply, you are getting the answer 6 into 10 to the power minus 2.
There are 2 methods actually. You can straight away use the formula or this
the
method
ratio
also.
method, right?
Ratio method also.
Both ways are perfectly
Possible.
fine, because when you cross multiply and find the answer, they will be the same as the formula method.
Formula method. But make sure you convert, you check the option, it is in gram. So make sure your 5 kilogram is converted to
into grams.
So again, unit conversion is very important in this one. And as if multiple choice question is given, it is important to see what are the units that are given in the
First we
final
have to
answer, right?
Final
Before doing any conversions, and based on the answers
Final
given
answers
in the choices,
yeah.
they should make the
There are
relevant.
choices how to do the conversion parts.
Sure. Okay. So this one is.
So this is opposite of what we did in sodium carbonate.
Okay.
Sodium carbonate, we found the mass. Now
Alright.
here they already provided that 11 gram is dissolved in 70 centimeter cube. So first you should find how many moles in 11 gram. So 11 divided by 142.1 will give you the moles. That is dissolved in 70. So mole over volume into 1000. So the mole divided by 70 into 1000 will give you the concentration in mole per dm cube.
Simple
So simple calculation, opposite of what we tried before. So the answer is, I think, 1.1 mole per dm cube. Okay.
In these concentration calculations, what are the major mistakes that are made by students? Like mainly.
There are some very few students, they actually still haven't got the point of 1000.
Okay.
Don't know
Yeah.
why. There are even some students argue, why do we need 1000? So they are not getting the point that either you express your concentration is normally in mole per dm cube or in gram per dm cube, but the volume must be in dm cube. And in this question specifically, your volume of solution you prepared is in 70 in centimeter cube. So it's important that the concentration unit is in dm cube, your volume is in centimeter cube. So in that case, some directly convert 70 divided by 1000, they make it to dm³ before they calculate.
Oh.
But some do the basic formula of mole over volume into 1000. Okay.
Ignoring the 1000 part, right? Conversion part.
Conversion part. And other than that, there are some mole calculation. It also need some ratio equation.
Yeah.
And some case they usually neglect that limiting reagent part, the mole ratio part, and they directly calculate.
Yes.
And the funny thing is those answers also in the
Multiple
options.
choice options.
So basically our belief is like my answer, it's there, so I can circle it.
Okay.
So basically a careful attempt, that is the first thing they should follow in MCQs.
Yes. So wrong answers wrong answers are also part of
because the marking scheme,
choice.
whoever prepare the marking scheme, they also know the basic mistakes they make, and that answer is also in the option.
Okay. Keep those in mind that you have to convert the volume into dm³. So if centimeter cube is given, always divide it by 1000, and at the same time take the correct number of moles of reactants, and you have to make sure that the limiting reagent is always considered in getting the final answer, right?
In 1.31 grams of chloride of titanium, there is 0.5 to 8 grams of titanium. Okay, the titanium mass is given, and the chloride of titanium mass also given. In that case, you have to keep in mind, first you have to find out the mass of chlorine. First you have to find out the mass of chlorine. I will do the calculation part on the board, but when you are doing the MCQ question, you don't want to do each and every step, you don't want to write each and every step. You can neglect these middle steps and you can get the answer. Right, this is another simple mole calculation question. So, and they ask you what is the empirical formula of this titanium chloride. We will think titanium, it is XCl(Y). It means the mole ratio is titanium to chlorine mole ratio is X to Y. So, and the mass of the titanium chloride is given, it is 0.528 grams, and mass of the titanium also given. This is the mass of titanium, and the mass of the chloride is given 1.31 grams. Okay, so in here you can see only titanium and chloride is there. In that case, titanium is given. So first you have to find out the chlorine, the mass of chlorine 1.31 grams, subtract 0.528 grams. From here you can get the answer for the mass of chlorine. It is 0.782 grams. 0.782 grams. After that, go for the titanium to chlorine molar ratio. It is X to Y. So in here titanium is 0.528 grams. This one is 782 grams. After that, you have to take the number of moles. Titanium, it is 47.9. Chlorine is 35.5. So by calculating this part, you will get 0.11 into 0.022. After that, we have to take the whole number ratio, divide by this small number, and it is 1 to 2. So the empirical formula would be titanium 1 is to chlorine 2. So no need to write this one, titanium Cl2.
Oh. Easy, right? So it's 1:2 ratio, and titanium is 1 mole, Cl2 is 2, so TiCl2 is the empirical formula.
So we have a difficult version of this in grade 12, I think. Combustion equations are there now.
Yes.
Yeah.
So I think they also asked to find empirical or molecular formula. That is a kind of, before I think in the grade 11 notes also we used to include without saying it, but now I think it's not there.
It's not there, but it's in the exam. In January 2020 paper, there was one question where the question is asking about an oxidation reaction of ethene.
Ethene.
Yeah. And that is one reaction which we have not taught
Yeah.
and also it is new.
Yeah,
So
it says it from a product which contain only one oxygen.
only
oxygen.
one single product.
Okay.
Yeah. So they have to work out the empirical formula of that product, without knowing
Without
what
knowing
the
what is
product
it.
is.
The product is.
That's the thing. So it's kind of asking students to apply their known knowledge.
Yeah, in the previous panel discussion, we had a question like that. I think some hydrocarbon burned to form this many
Yes.
moles of carbon dioxide, this many moles of water.
Water.
Then we have to work it out. What is the empirical formula, molecular formula of the
Molecular formula
hydrocarbon?
of the compound. Yeah.
Okay.
So those are some of the questions that we have received for this session, and I think students, you have got an idea on how to work out the questions that you have asked, and we hope to receive more questions and doubts that you have in the future sessions. So thank you very much.
Thank you.
I hope this session has been helpful for you. Thank you.